In Course Tech 001C, you will find the Zeiss Xradia Versa 520 3D X-ray microscope, a groundbreaking tool for non-destructive tomographic imaging and grain reconstruction. This instrument is designed to reveal both surface and internal details with precision, making it indispensable for analyzing advanced materials and understanding their mechanical behavior. X-ray computed tomography collects many X-ray projections of the sample to generate high-resolution, non-destructive 3D renderings of your samples. These renderings help identify material phases and defects, such as porosity, providing crucial insights into material structure. The Zeiss Xradia uses absorption contrast tomography to achieve ultra-fine resolution down to 0.7 microns, with a variable energy range from 30 kilovolts up to 160 kilovolts, allowing analysis of biologic materials, minerals, as well as metallic materials. The Zeiss can also utilize phase contrast tomography and dual energy tomography to enhance detail at phase boundaries and enhance compositional contrast. It can also operate in diffraction contrast tomography mode to deliver direct 3D crystallographic grain reconstructions for crystalline materials. This capability is critical for analyzing grain orientations and sizes, enabling advanced studies in material science. Our unique setup combines our 3D imaging capabilities with an in situ load frame, allowing correlations of defect structures with mechanical behavior under tensile or compressive forces up to 5 kilonewtons. Following collection of the tomography, we have advanced software and image analysis tools such as Dragonfly to segment your 3D renderings and provide statistical analysis of features such as pores or inclusions. From material analysis to defect detection, the Zeiss Xradia 520 Versa 3D X-ray microscope is a powerful tool for driving innovation in materials research.